Good morning. Today we are going to be reviewing for chapter 1 and 2 tests. This is going to be your first test that you guys are taking in my class. Now remember that you want to be able to work out each of the problems first before you actually watch the lesson. Work out the problem, then if you don't get the correct answer, come back and check and see what you did incorrect. Problem number 1. We are going to solve the following equation. I'm going to draw my line. Many of you guys are tempted to combine or negative 6 minus 2. You want to make sure that you want to be able to distribute not the 2, but the negative 2 first. The negative 6 comes down, negative 2 times 2x will be negative 4x. Negative 2 times 6 will be negative 12. Some of you guys are giving me the incorrect sign here. Be careful. We have 2x plus 6 comes down. We are going to be combining like terms before we start to move things left and right. We have negative 4x minus 18 is equal to 2x plus 6. Now I can go ahead and solve the equation. I'm going to move my 2x to the left, my 18 to the right. That is negative 2x, and that becomes a positive 18. We have negative 6x is equal to 24. From here, I'm going to divide by negative 6, divide by negative 6. That cancels, and the answer will be x is equal to negative 4. Problem number 2. Solve the following absolute value inequality. First thing that you want to be able to decide if this is an AND or an OR. Remember, if it's less than, that's an AND, greater than, or greater than, greater will be an OR. This is less than, greater. In this case, this is greater, so this will be OR. When we have absolute value, we have two solutions. So we have to divide up in two different inequalities. The first one will remain the same. 7x minus 3 is greater than 2. The second one will be the opposite. This is a positive, will be a negative 7x. This is a negative, will be a positive 3. Notice that the greater than 2 stays the same on both. I know some of you guys solve it differently, which is fine as long as you get that correct answer. Move my 3 to the right becomes a positive 3. That gives me 7x is greater than 5. We are going to divide by 7, divide by 7. That cancels, so x is greater than 5 over 7. On the right hand side, we're going to go through the same process. Move my 3 to the right becomes a negative 3. That is negative 7x is greater than negative 1. We are going to leave the x by itself by dividing by negative 7, so we can cancel. Remember, whenever you divide by a negative number, you have to flip the inequality. Negative divided by negative is a positive, and it gives me 1 over 7. And it's an OR in between. If it's an AND, remember that you want to be able to connect them. If it's an OR, we can just leave it as is with an OR in between. Problem number 3. I want to be able to graph the following function. It's already in slope-intercept form. If you notice, we have our y-intercept, we have our slope, and the y-intercept. So this form is already in slope-intercept form. So it's a very quick process to graph. Negative 2 is my y-intercept. My slope is negative. It's a negative 2 over 5. The negative belongs to the top number. That is negative 2 over positive 5, or the bottom one, but not to both. We are going to assume that it belongs to the bottom one, so we're going to go down 2 and to the right 1, 2, 3, 4, 5. Or we can do the opposite. 2 and 2, 4, 5. This is not an inequality. So you don't have to think about whether shaded or dashed. This is just a solid line. All those points are solutions, are part of the line. Remember that visually, or in your head, or I prefer if you actually write down the word slope, it's going down, that's negative, it matches. If your slope is negative, but the line is going up, you know there's something wrong. Problem number 4. What is the complete solution? Once again, we have an absolute value inequality. That means that we're going to have two solutions. The first one will be the same, 2x plus 7 is equal to 1. The second one will be the opposite. That's a positive, will be negative 2x. That's a positive, will be negative 7. And remember, whenever there's an equal sign, just an or in between. And we're going to graph or solve each equation separately. Move my 7 to the right becomes a negative 7. 2x is equal to negative 6. We are going to divide by 2. And that will give me x is equal to negative 3. We are going to do the same thing on the right hand side. Move my 7 to the right becomes a positive 7. That gives me negative 2x is equal to 8. I'm going to divide by negative 2 to leave the x by itself. Gives me x is equal to negative 4. And an or are in between. So x is equal to negative 3 or x is equal to negative 4. Let's continue with problem number 5. Problem number 5, graph the following function. We have an absolute value equation. First, we need to be able to identify a vertex. Our vertex will be our h and our k. Remember, your h is always the opposite. It'll be negative 3, so this will be a positive 3. This is a negative 6, it remains the same. The h is the only one that changes. This is your h, this is your k. Let's go and plot it. To the right 3 and down 6, 2, 4, 6. That'll be your vertex. Next, we need to draw the line of symmetry. And we need to write the equation of the line. It's a vertical line, so we know it's going to be x is equal to a number. And where does it cross the x-axis? At 3. So x is equal to 3. From here, because we are still talking about a linear equation, and we can use the slope, it's a negative slope, to find the other points. It's negative 1 over half. Down 1 to the right 2, down 1 to the right 2, or the inverse, or the opposite. From here, we can connect the points. And that'll be our graph. We need to decide whether the vertex is the minimum or the maximum. If you are walking on this line, will that be the highest point or the lowest point? That'll be the highest point. Therefore, that's our maximum. And our graph or function is facing down. The last thing it says, the function is wider or narrower than y is equal to the absolute value of x. We want to be able to compare whether this function, the one that we just graphed, is wider or narrower than this one here. Just the basic graph, y is equal to absolute value of x. Remember, the coefficient or the a value is 1. So let's say 1 over 1. We want to be able to graph it on the same vertex and facing down as well, so that way we can compare. If you actually want to place it at 0, 0 and graph it so you can compare, it's fine. But I prefer to graph it on top of each other and facing the same way, so it's much easier to compare. 1 over 1, 1 over 1, here and here. Once again, 1 over 1, here and here. And I'm making it red so we can actually see it. Is the original graph wider or narrower than the red one? It's actually wider, as you guys can see. Problem number 6. Graph the following linear equation. One way to be able to graph this is to be able to rewrite it in slope-intercept form. Leave the y by itself. Let me write down on the left-hand side, 3x plus 4y is less than 16. To transfer it to slope-intercept form, I'm going to move my 3x to the right, becomes a negative. That gives me 4y is less than negative 3x plus 16. Leave the y by itself, I'm going to divide by 4, divide by 4, divide by 4. The 4's cancel, y is less than, negative divided by positive is a negative, plus 4. My y-intercept is 4, that's where the line crosses the y-axis at 4. My slope is negative, I'm going to go down 3 to the right 4. 1, 2, 3, 1, 2, 3, 4. And I can do it once again. 1, 2, 3, 1, 2, 3, 4. Or the opposite, up and to the left. Several things to think about when you graph an inequality. Is this going to be a solid or a dash? This is y is less than, that means it's going to be a dash because it's not equal to. So it's going to be a dash line. Make sure you place arrows on both sides and make your line all the way through. Remember, the points that are on the line, are they part of the solution? No. If this is a dashed line, the reason that we place it as dash because those points that are on the line are not part of the solution. If it was a solid line, because it was less than or equal to, if it was a solid line, then those points will be part of the solutions as well. Y is less than, that means that we're going to have to shade the low side, the bottom part. Remember, less than is going to be the low side, the bottom part. Greater than is going to be the top side. And we just shade the bottom part. Perfect. That means that all those points that are shaded are part of the solution. So if you select this point and plug into the inequality, that gives you a true value. Any of those points that are shaded are part of the solutions. The points that are on the line are not because the line is dashed.